Hello students, in this video we are going to look at the last category of operators that are of interest to us, logical operators. Now logical operators in C are essentially just three. You have the logical AND, the logical OR, and the logical NOT. And these work on char, int, float, and double. These are the data types on which they work. Other data types they don't work on. In all of these cases, in the same way that you had the relational operators return either 0 or 1 based on whether the condition was satisfied or not, for logical operators also the output is either 0 when the logical operation fails or is false, and it returns any other value to represent true, but the compiler returns 1 by default. If you remember your logic, then you know what both and or do. If E1 and if the expression 1 evaluates to 0 and E2 evaluates to 0, then E1 and E2 will evaluate to 0. If E1 is false and E2 is true, then also E1 and E2 evaluates to 0. Only when both E1 and E2 are true does E1 and E2 evaluate to 1. On the other hand, E1 or E2 evaluates to 1 if either both or at least one of the two expressions E1 and E2 is true. And for not, this is again straightforward. If the original expression is false or not true, then the negated expression is true, and vice versa. This is what logical operators do, and here we look at some examples of how they work. So the top few examples are trivial, but still instructive. 2 and 3. What does this evaluate to? Well, 2 is not 0, and 3 is not 0. Both are non-zero values, so the result is 1. 2 or 0, at least 1 is non-zero, so the result is 1. A and 0, both of these evaluate to the respective integer values corresponding to the ASCII codes, both of which are non-zero, so they evaluate to 1. See, this is not 0, this is the character 0, which has an ASCII value which is non-zero. On the other hand, if you said A and 0, where 0 is the number itself without the quotes, then this would evaluate to 0. A and B both evaluate to a non-zero integer each, so the AND of them evaluates to 1. Not of 0.0 evaluates to 1 because 0.0 is guaranteed to be 0. It's a special condition that is handled in between floating point and integer representation. Not of any non-zero value is 0. This is also defined at the compiler level. And this expression, here you will see that first we have to examine the conditions within the brackets. So 2 is less than 5. This is true. The LHS is 1. 6 is greater than 5. The LHS is greater than RHS. So the whole thing evaluates to 1. So you have 1 and 1, which gives you 1. This is how logical operators are evaluated. Not has the same precedence as the equality operator. If you remember the relational equality operator, not has the same precedence as that, but and or are lower than the relational operators. So there's a subtlety here where and or have a lower precedence than not, and in fact or has a lower precedence than and. Associativity goes from left to right. Now what does this mean in practice? Here we have this very complicated expression. And what we want is we want to evaluate this whole expression and boil it down to one single value. So how do we do this? First of all, we have to say that the equality operator and the not operator have the same precedence and they are higher than and or. Therefore, the equality operators have to be processed first. And the associativity for equality operators goes from left to right because they're relational operators for whom the associativity goes from left to right. So across the whole expression, we just go from left to right and we evaluate all the equality operators. 2 equals 2. That is correct. So we put 1 here. 3 equals 1. That is false. So we put 0 here. 1 equals 1. That is true. So we put 1 here. 5 equals 4. That is false. So we put 0 here. All the equality operators have been evaluated. Next, we know that AND has a higher precedence than OR, so we evaluate the AND. 1 and 0 is 0, so we put a 0 here. Then we have OR left, and the precedence here goes from left to right, so we evaluate 0 or 1, which gives us 1. And then we do 1 or 0, which gives us 1. This whole complex expression has been evaluated to boil it down to a single number. And so if we look at this expanded table of operator precedence, we can see that the logical operators fit in towards the lower end of the table, where the equal and not equal operators essentially take the negation operator along with them. And below them is and below them, right above the assignment operator, are the OR operator. And so you can see that the precedence table here is pretty big, and you will think, well, how do I remember all this? This list doesn't include some other operators that we have not yet seen. How do you keep track of all of this? Well, the answer is you have to practice, and when you practice, this becomes second nature to you. So get on to Pruter, and let's see if we can evaluate some complex expressions.